When you start your exam, and now this you can start looking on the piece of paper. You have to first ask yourself 3 questions. Number 1, what has been given? Okay, can I just quickly say the following for you to actually think about this? Is a conscious decision. This is not going to come naturally to most of you. What deductions are there from the standard forms, theorems, formulas? And then the last point I do want to quickly just point out for you, that last little point. Elimination of irrelevant theories and formulas. What do I mean by that? The question is about parabolas. Okay, great. Now I open my toolbox. I think about parabolas. Do I have to think about hyperbolas? No, so I don't have to worry about asymptotes. I don't have to worry about log functions. I train myself to put those things aside and only think here. A professor at the University of Stellenbosch said this is one of the main reasons why students fail calculus. They try and look at all the maths all the time, and you can't. Is there any of you that's going to study AXI, Actuarial Sciences? Okay. Hey! Your first year June exam is about 470 pages in one textbook in one of your 6 subjects. Calculus. You learn to be very clever at eliminating things you don't need because they're not relevant. Same with if you go and study things like being a doctor, dentist. If I'm a doctor and a guy's knee is sore, I'm not going to be worrying about his back, his vertebrae in his back, or the headache. I'm going to focus on his knee. So please learn to eliminate what is irrelevant. Second question. What is the question really asking? So, I love to call it the monkey behind the mountain. What is it? The question is, prove this thing is a cyclic one. That thing is not, that's not actually what they're asking you. They're actually asking you to maybe prove this angle equal to that angle. That's actually the question. Or prove this thing squared is equal to that times that. 7 marks. Actually, they're asking you to prove 2 triangles similar to one another. That's the question. That's what I like to call the monkey behind the mountains. A very important thing, what is my RTP required to prove? Ladies and gentlemen, here's a scary little thing. In geometry, if you can write down what you need to prove, even if you can't do the sum, you get 1 mark. So if they say to you, prove this line is a tangent to this imaginary circle, okay, RTP, that angle must be that angle. That's 1 mark. If you didn't know that, now you do. Third question, and this is the most difficult question. How can I answer the question? As George Polya said, 1 problem, 5 different ways. For those of you that are 80s and 90%ers, you have to find at least 2, 3 different ways. Because you don't know what the examiner is going to come up with. Even though the IEB examiner, paper 1, is one of my close mates, I don't know what the hell he's going to ask. My friend, my students have asked me to bribe the guy a few times, but no. Okay. I don't know what's coming. I'm all right with that. My students are not, but I am. So when you practice, challenge yourself to find at least 2 methods to solve that problem. If you can, 3 or more, if you've got time. But plan your sum. I'm going to do this, then I'm going to do this, then I'm going to do this. Because a lot of times in your planning, you are seeing the fallacies of your own thinking. I want to do this is equal to this. And then I'm saying this is equal, wait, no, this is nonsense. Okay, let me try a different thing. Plan the sums out. And a very important thing about planning your sum out, and this is why I want to challenge you guys to do it, is mark allocation. I've seen so many times. This past week I had my grade 11s. I love them. And this one guy, well, him and his mate, they are such hard-working students, but most of the times, they want to go to Cape Town via Durban. So they want to go to Cape Town, but they're traveling all the way. And then I'm like, but didn't you see that thing is a cyclic quad? Oh, sir. So I didn't have to do 5 steps, I could have done 1. Because understand, there's only 2 kids who finish a maths exam. The kid who knows everything and the kid who knows nothing. That's realities. Okay? Be clever about it. Now, okay, that is for this PDF. You can, it's on there, I think it's got printed as well for you guys, is it not? Snap a photo of that. That is to get this thing on PDF, okay, for this one. So if you want to whip out your phone, snap, not a selfie please, okay, but you can snap a PDF, the QR code for this. You can then have it and keep it at home. So what I would like you to do, and you know what guys, it's already been an hour, #just saying. Yeah? I wish maths would go by this fast, right? Yeah. Okay. What we are going to do for this next hour is I am going to put up certain sums. I'm going to give you 5 minutes. Not to do this lesson matrix. Because I know half of you are fast asleep. Lesson. Don't answer the question. Plan the sum. That's all I want you to do. I want you to take this question, for instance. And I don't want you to answer the sum. I want you to say, ask those 3 questions for yourself. Number 1, what was given? What are they actually asking me to do? Thirdly, how am I going to get there? And I want you to think of 2 different methods of solving this sum. You are allowed to work with your mates, and I am going to give you, just for this first one at least, I'm going to give you 10 minutes. And then we'll come back and we'll talk about this sum. Enjoy it, ladies and gentlemen. So, let's go through the information. A golf ball is hit from point A to point B. Okay, so let me just quickly get to my slide. There we go. Come on, baby. I love technology. Okay, there we go. Okay. So a golf ball is hit from point A to point B. I wish we could hit golf balls like that. They usually go much lower in very wrong directions. But yeah. A golf ball is hit from point A to point B. Point A is 30 meters vertically above the ground. I'm going to jump ahead a little bit. The path of the flight of the golf ball is placed in the Cartesian plane so that A is on the y-axis. Okay. There, I like that. So actually, there's a y-axis and that's the x-axis. Sorry. Oh. The math she's broken. The math is not mathing at the moment. Okay. Here we go. So y-axis and x-axis. Okay, great. Walter, what is that? Point A is 30 meters vertically above the ground. Tell me about the graph.
About the graph, sir?
Yeah.
Well, that's the y-axis.
Danko. So in other words, it is a parabola, so C is 30. So it is 0, 30. I don't think there's more, right? Okay. Now we get to interesting points here. Point B is 300 meters away from A at the ground level. What the hell does that mean? So what do you say? X-intercept. Okay, I like it. Okay. So x-intercept, so I'm making connections here. So my x-intercept is at 300, 0. Okay, I like it. The path of the ball is modeled by y equal to ax squared plus bx plus c. Why is this important? You tell me quickly. So in other words, this is the ball is modeled by by the equation of a parabola. But please again understand, let's quickly jump to question 2, let's make connections. Please remember, ladies and gentlemen, that I could also write this as this. Or I could write it as this. Okay, so I've got 3 options at least. Okay? Can somebody please tell me, how do I get from this form to that form? Yes? Oh, you are a fantastic student, because you do exactly what your teacher told you to do. Your teacher told you to do that, right? What is the second option? So I can find the x value of the turning point, and that gives me P. The y value of the turning point, and that gives me Q. And then I have the A that I can read off. So do I actually have to complete the square? So completing the square is useless, right? I love how you guys say yes. Then you get to first year varsity and the professor tells you, please rewrite it from this form to that form by completing the square. And there's no other method you can do. Is it coming? Calculus. Ladies and gentlemen, there is only one way sometimes of doing things and completing the square. You have to practice for calculus. So please go and practice completing the square. Just do 2 or 3 of them. I try to avoid it because my students suck at it. Okay. But you've got to go and practice it for first year varsity. Now, so, the ball passes through the point 200, 30. So what does that tell you? Please tell me. So what's your name? Milani. Okay, what does that tell you? It is some random point, right? It is some random point there, 200, 30. Right? It is just some useless random point. Okay, great. So glad no one objects to my uselessness of that point. Is it not useless? Why is it not useless? Yes, Walter?
So because it's the same y coordinate, halfway between that you'll find the turning point.
Oh my goodness. I can see he's in an IEB school. Not because he's so clever, but the past 4 or 5 years, if you can't think about symmetry, you can't answer the matric final papers. Ladies and gentlemen, always look for symmetry. I have 2 y values that are exactly the same. 30, 30. Exactly in between these 2 x values, between 0 and 200, you are going to find your axis of symmetry. In the IEB schools, the government schools not so much. But in the IEB schools, the past 4 or 5 years, you couldn't answer the matric exam papers if you do not think about symmetry. What is beautiful here is what's the other x-intercept? Somebody said it there at the back? Negative 100. Why is it negative 100? Because symmetry. There is 200 between those. There is 200 between those. So if this line had to continue, it is going to cut at negative 100. So I could use that formula. I could use that formula. Or if you're not clever, not that clever, you could use that formula. Why do I say not that clever? Because some of you would have just randomly plonked in points and hope and pray you get to the answer. That's all right. I'm not judging you too harshly. But ladies and gentlemen, that would be a hell of a lot of extra work, am I right? The reality of it is, most of you would have given up. So I encourage you to not just run into a problem like this, but plan it out. Now let's quickly look. Determine what? Now we get to the actual question. The maximum height. In other words, the question is actually about the turning point. Now the beautiful thing is, if you were clever, you already know the x value is 100. Now, I just need the y value. But now let's think about planning this sum out. How do I get a y value on a graph? Substitute the x value into the equation. So what do I need first? The equation. So I've got to now think, how am I going to get the equation? Well, I've got 3 options. Easy, medium, difficult. Your choice. I would not use actually this one. y equal to ax minus p squared plus q. I would use that one because I've got the 2x intercept. And then I can just substitute in to get the a value. And then I just substitute in to get the corresponding y value. Ladies and gentlemen, as you're practicing, stop doing it alone. Start practicing with mates. Come one Saturday morning, 5 or 6 hours. Sounds a lot until you start practicing. And then you guys attempt the sums. Question 1, and you do the question, okay, let's compare notes. How did you do it? How did you do it? How did you do it? Man, what the hell were you thinking? And then they tell you, you're like, oh, flip, I never thought about that. It also helps to have a really, really clever person in the room, you know? It really does. That's why I always had my friends over, because they're much cleverer than I am. Not just joking, I'm the cleverest guy in the room. Okay. And so humble. Okay. Ladies and gentlemen, let's get back to the practice. Okay. I want you guys, there we go. I want you, okay, now I'm just going to give you 5 minutes. Plan out your sum. In a geometric sequence that is given, Tn is that, determine the value of W. You have 5 minutes, ladies and gentlemen. Plan it out for me. And again, if you are clever and you're done after like 2 minutes, get a second or third option. Not wrong. Not wrong. Okay, just for interesting, what is your album? What's your album? What's your album?
Well, the first one is going to be W, the third, 12, well, minus 1, so it's going to be a third W, and then it's going to be a nice W, and then a 9 divided by a third is a third.
There's another paper.
Is there another one? Okay, I'll figure it out.
You're gonna go for. Okay, ladies and gentlemen. Okay. Typical IAB question. Definitely. Our IAB examiners love it. They love to kill students. Because it's not difficult. In a geometric sequence, okay, so let's look at question at the first option. So let me just again get it here. Okay, boom. There we go. I'm going to quickly, oh, so many things I've done. There we go. Okay. In a geometric sequence, okay, so what do I know? And what does that mean? It sounds silly, but I really honestly believe, I want to quickly say something interesting. My father-in-law, I love my father-in-law. Number one, he looks like Paul Kruger, really, really, really does. He's actually descendant from Paul Kruger's cousin. He said an interesting thing, and those of you that have lived your whole life believing you get math people and you get language people, my father-in-law said something very interesting, because he has a Bible translation company. Where they have, I think at the moment, about 1,000 translators from all over the world who's translating the Bible into those people's mother tongues. And he said something interesting. He said the best Bible translators in the world, no, I'm lying, not the best Bible translators, the best consultants, those are the people that check the Bible translators, are scientists. Because it's exactly the same thinking that goes into languages, goes into doing maths and science. And it is the truth. Because whether I say you are an idiot, or whether I say you are the idiot, small difference in word, big difference in meaning, okay? That's why I place so much emphasis on words. Like it tells me it's a geometric sequence. Okay, therefore I don't have to look at quadratics. I don't have to look at arithmetic. I can only look at geometric. So in other words, I know automatically A is term 1, R is term 2 over term 1, Tn is equal to AR to the n minus 1, Sn is AR to the n minus 1 over R minus 1. That I know. Okay? If you swap the R and the 1 around, I'll forgive you as long as you do it top and bottom. Okay, now we can quickly go to S5. Automatically, before I do anything, I bring in a formula. Another reason why a lot of matrics and grade 11, but matrics get things wrong, is they just go, oh, and then move on. No, go, oh, what does it mean? And then you move on. So if I look at S5, automatically I know that S5 is AR to the 5 minus 1 over R minus 1. And this must equal 605 over 243 must be equal to AR to the 5 minus 1 over R minus 1. Everyone all right with it? Yes. Great. Now let's quickly look at the next little bit of information. And Tn is that. Okay, so Tn, which is A times R to the n minus 1, must be equal to W times 3 to the negative 1. Easy class. Okay. Problem? Do not be in a hurry. That's not rocket exams. I know. A lot of students said R was 3. I already hear some giggles here on the left. R can't be 3 because in this one, R is a positive, and in that one, or N is a positive, and in the other one, N is a negative. So you cannot just read off and go, R is 3. Okay? There's something else also that tells me R is not 3. But this is, and you said something earlier, Miss, that it is experience. I see that divided by 243. And that is 3 to the power of 5. Now you're just like, how the hell did you get that so quickly, sir? I'm just awesome. I'm not awesome like that. That kind of tells me, ladies and gentlemen, that my R should be a fraction, like 1/3 to the positive n. Now I can say R is 1/3 because I'm comparing 1/3 to the n and R to the n. And those of you that do further study mathematics knows our favorite method of solving equations is look what's happening on the left. What's happening on the right? Well, left must be right. So whatever's on the left must be equal to whatever's on the right. That was the other method that I wanted you to see. Okay? Compare left and right with each other. R must be 1/3, but it only happens because positive n's and positive n. What else can I get? Well, I can get T1. W over 3. That's just plugging in with 1. Now what must I do? I'm going to take these values, I'm going to substitute them in to that formula. No, sorry, wrong one. I'm only seeing half of the picture here, sorry. Into that one, and into that one. I've got R. The question is, solve W. So now I'm going to sub in and solve because I've got R's value I've got A, then you're just going to solve. And honestly, guys, this is our little tricky exam. IEB, tough, sometimes. But ladies and gentlemen, let's move on. Because time is running out. You've got 25 minutes left. Okay? Now, Okay, so I'm going to ask you, just give a moment before you jump into anything. I'm going to give you 5 minutes to just analyze the information and put whatever you've got on the sketch. That's it. Take 5 minutes and do that, and then we'll worry about the rest. Okay, ladies and gentlemen, let's quickly go through this. Okay. So let's quickly look at this, and let's try and. Okay, there we go again. There we go. In the diagram, TR is a diameter. So it's really weird that they've got this weird little squiggly dot there. I'm reckoning that we can assume that's the center of the circle. No, you can't. Because they didn't say it to you. There's only 2 things you are allowed to assume. Number 1, cyclic quads. Number 2, straight lines. Like I can assume TPS is a straight line because it looks like a straight line. I may not assume tangents, centers of a circle, parallel lines. Those have to be given. Grade 12s, please, 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 never assume tangents. I've seen so many times that line bloody well looks like a tangent. Everyone uses it as a tangent. And then question B asks, prove it is a tangent. Now you've answered the whole of question A because it is a tangent. Now they're asking you, prove it is a tangent. You're like, I'm screwed. Next question. Please, please, please. So let's quickly go through this. TR is a diameter. So TR is a diameter, which therefore means I can only use theorem 3. If I've got a diameter, I've got 90 degrees all around there. Be careful. Also, if there is a tangent and a diameter, I can use theorem 7. A radius perpendicular to a tangent. Please be careful of that. Let's move on. BRKT is a cyclic quad. Okay, sorry, I apologize, this is a DBE paper. They're not going to tell you always it is a cyclic quad. The IEB never does. So please look out for it. So I go take my coloring pen and I color in my 2 halves. So automatically I have that angle, 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 that angle. Automatically. I go and color in all I've got. Theorem 5 I'm not going to worry about because I'm lazy. No, because I don't have real values except for the 90s. But P1 is equal to T1 and 2 or R1 I mean, P3 is equal to, well, 90. Okay, but that's not much of a problem for me. It is a 90, so let's put it in as a 90. Why? Because I can. Okay, chords TP and KR are produced to intersect at S. So in other words, they're extended, meaning it's straight lines. Chord PK is drawn such that PK is equal to TK. So I have this line, this beautiful line here, equal to that beautiful line there. So automatically I'm looking for isosceles triangles. So that angle there is that angle there. Okay, let's hit the pause button. So automatically P1 is T. But T is also equal to R1. Okay? Which might come in useful in the future. Have I looked at any of the questions? No, but I've already answered most of them. I have. I'm a clever cookie sometimes. Just sometimes. Let's quickly look, ladies and gentlemen, at the actual questions. Question 10.1. Prove that SR is a diameter of the imaginary circle. Okay, let's think. Now we get to question 2. What are they actually asking you? Prove that?
P3 is 90.
But we have that. Because if P3 is 90, it must lie opposite a diameter. Oh, so I've just now got to write it down. So this is the way I do geometry, and therefore I will always get 80% for geometry. SR is a diameter, so my RTP is that angle P3 is 90 degrees. So now I've got to ask myself, how can I do that? I've got two options. P1 and 2 is 90. So I can relate this to P1 plus P2. And therefore angles on a straight line. Ta-da! I've planned out my sum. So I was going to write it out better for the examiner, but now I know exactly I've got to do 2, 2, 2, 2. My problem that I have with the way most students do geometry is they kind of do this. Blah, 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 blah. Oh, okay. Prove that SR is a diameter. How the flippin' hell do I get P3 to be 90? And then all of a sudden they try to go back at the information. Not going to get geometry right that way, I'm sorry. You're going to struggle yourself to pieces. Next question. Prove that S is equal to P2. What the hell, what am I going to do? I'm going to be clear. Make S X. Let S be equal to X. Because if I can then prove that P2 is also X, then I know that they are equal. Okay, so let's try. I haven't done this. How many marks? Oh, 5 marks. Oh, this is a difficult one. So let's say S is X. exalted. Oh, this boy's on fire. Ladies, you're looking for future husband, you know, this man's on fire. You know? Yeah, Walter.
So what you're going to do is, obviously we proved, so we'll prove the angles that we already have, that we're going to be using. But, so we can see that R1 and P1 is equal.
Okay, here he gets to a very important thing. Do not forget what you already did. You already have R1 being equal to P1. Use it. Okay? Okay, yes?
Yes, so then what we're going to say is, we're going to say, well, we know P1 plus P2 is equal to 90.
Yeah?
Angles in the semicircle.
Okay, so I'm working with a P2 here. So P1 plus P2 is 90. So automatically I can say, well, P2 is 90 minus P1, right?
90 minus P1, yes.
Yeah?
And then we'll keep that in mind. And then we're going to go R1 is equal to, was it 180 minus 90? Right, yeah. Yeah, so then you have
180 minus 90, yes?
Yeah, minus, yeah, so then, which is...
Minus?
Oh, sorry, minus P3, sorry. No? Sorry.
R1 is P3 minus 90 minus?
Sorry, minus S, sorry.
Minus S.
Minus S, sorry.
Yeah.
So then, which is 90 minus S?
Okay, so I've got this is 90 minus
S, minus S.
S. So in other words, this is 90 minus X.
Yes. And then we said that R1 is equal to P2.
Okay, so R1 is equal to P2. Well, we actually haven't proved it.
Okay, so we can prove that.
So R1 is equal to T,
Yeah.
which is equal to
Which is equal to P1.
P1. So in other words, R1, or P1 I mean, is 90 minus X. But what do we know about P1 and P2? No, P1 and P2. 90. So in other words, so P1, so this is 90 minus X. Plus P2 must be 90, so P2 must be well done. There's some beautiful mathematics here. Future mathematics story here. I love it. Walter, just look me up on LinkedIn in a few years. I want to track your progress. Ladies and gentlemen, as you can hopefully clearly see, I do not walk into a sun like this, all just, I'm just going to go home. You need to plan the sun. Now, when I look at the last one, and I'm not going to go through all of this because unfortunately time is against us. They're asking me to prove that. I.e., what are they actually asking me? Prove that angle is equal to angle P what? P or K? P2. Oh, we just did it. Prove that angle P3 is equal to angle R. Sorry, let me just quickly let me quickly color in my triangles. Triangle SPK, SPK. So that one there, and triangle PRK. P, R, K. So I have angle K2 that is common. I have already proven SPK. P, S3, or S equal to P2. So I already have a common, let me just erase this. Let me just try to make this. I already have angle S equal to P2. I have angle K that is common. Automatically it is similar. And now some of you guys go, okay, next question, right? Or do we go, okay, now you write it out and everything. You go, next question, right? No! What do you do? Oh, sorry, sir. SP over PR is equal to SK over PK equal to, is equal to PK over RK. This follows directly from similarity. Before I do anything, I write that down. And now, ladies and gentlemen, I want to end off with something very important. You guys can go and try this and these sums yourself. It's beautiful, it's lovely. Do not forget at this moment, especially government school students, DBE school students, do not forget, if there are parallel lines, you can use proportional theorems as well. That's a lot of times what happens in this last, because this would be the last question of the exam, that they bring in similarity with proportional theorems. Okay. So ladies and gentlemen, I told you guys 2 hours are going to go by quickly. Quickly take a snapshot of that. And we're finishing off with this now. If you go on to that QR code, but I'm going to ask you guys, give it a chance till tomorrow. Maybe, if you can wait that long. I'll give it to you guys again tomorrow. I want to just upload the newest version on everything on this QR code. So I'll give you guys a chance again tomorrow. There I uploaded my not most recent ones, it was last year's one. But all the theory you need to survive your maths exam. And you are most welcome to spread this to all your friends. I don't mind. Print out the books. Spread. If you've got mates that are in grade 11, spread it to them. I don't care. I don't make a single cent out of it. That's just how I roll. Ladies and gentlemen, I encourage you to remember the following. You're only through 25% of your life, if you are blessed enough to live to 72. Please make the most of it. These next 3 days, as the facilitator said earlier, these 3 days you will never again have in your life. Don't let your own hang-ups. The Afrikaners have a saying, "Finis," which literally means, I don't like to do this, or this is not usually, I don't usually speak to people. I just sit in the corner and, I'm happy. Venture out. This opportunity will not come again. Make the most of it. Enjoy it. I think there's physical science coming up later as well. So enjoy it. And we'll see each other tomorrow, I think 1:30. And we are going to tackle the chapter on probabilities. Because I know you guys suck at probabilities, okay? So I'm going to see you guys tomorrow. Enjoy the junior types, guys. Enjoy it. Sleep well tonight in the hotel. And I'll see you guys tomorrow. Cheers.